Have you ever been at the campfire as it dies down or as someone adds more fuel? Your reaction is a good representation of the inverse square law. Too intense? Step back and increase distance. So likewise, standing farther from an X-ray source drastically reduces radiation exposure. So why does changing the distance from the X-ray tube affect image brightness? The answer lies in the inverse square law, a fundamental principle in radiology. Or, a campfire, let's break it down. The inverse square law states that the intensity of radiation is inversely proportional to the square of the distance from the source. In simple terms, as you move twice as far away, the radiation intensity drops to 1/4 of its original value. I1 over I2 equals D2 over D1 squared. Here, I1 and I2 represent radiation intensities at different distances, D1 and D2 from the source. This means small changes in distance can have a big impact on radiation dose and image quality. As an X-ray technologist, keeping the patient at the correct distance from the X-ray source ensures proper image quality while minimizing unnecessary exposure. For example, increasing the distance doubles the safety while reducing patient dose by 75%. Now, what about X-ray images? If we increase the source-to-image distance, SID, the beam spreads out, making the image appear darker. To fix this, we must adjust the exposure settings, following this formula. MAS1 over MAS2 equals the square of D1 over D2. By increasing MAS, we compensate for the reduced intensity and maintain image brightness. Section 4. Radiation protection. Why distance matters for safety. In radiation safety, distance is your best friend. The farther away you are from a radiation source, the less exposure you receive. This is why technologists step out of the room or use lead barriers during imaging. If you double your distance from a radiation source, your exposure drops to just 1/4. Triple the distance? It drops to 1/9. Section 5. Quick recap. Let's recap what we've learned. Check mark. The inverse square law means radiation intensity decreases as distance increases. Moving twice as far away reduces intensity to 1/4. Patient dose decreases with increased distance. Image brightness is affected, requiring milliamperes adjustment. For safety, increasing distance reduces radiation exposure significantly. Closing scene. And that's how the inverse square law applies in diagnostic radiology. If you found this helpful, hit the like button and subscribe for more radiology tips. Got questions? Drop them in the comments below. Thanks for watching.